Good morning to everyone. I'm Dr. Yo Boon Jin, Senior Lecturer from Faculty of Engineering and Technology, as well as the Chairperson of Center for Advanced Robotics. The Center for Advanced Robotics was established with the objective to focus on research and development of advanced robotics and industrial automation, the advancement of knowledge in this field, and the development of technology based on the knowledge gain. The Research Center also aims to foster scientific excellence at the international level in the fields of robotics and automation. Some of the research projects in the Center of Advanced Robotics are related to robot motion, robot positioning, robot perception and intelligence, sensor system, vision system, battery development, solid-state electronics, and many more. I'm the moderator for today's webinars. On behalf of the organizer, I would like to welcome all of you to our Humanizing Innovations at MMU Webinar Series. Thank you for sparing your time to be with us. So let us begin. Automation is the key to success in Malaysia digital transformation for Malaysia to become digitally enabled, technology-driven, high-income nation. With automation, employees can focus on high-value tasks, enabling them to augment their skill set with emerging capabilities. Consequently, organizations can drive more strategic competencies across their business, giving them economic advantage over their competitors. Although the pandemic has changed the world economy, it has boosted the transformation and automation works across the industry in Malaysia. So once again, welcome everyone to this webinar. In this webinar, we will see how automation and digitalization can bring changes to manufacturing environments. The topic for today's webinar is automation and digitalization of manufacturing environment with industrial revolution in mind. So with me today, we have two experts. Mr. Lam Chi Chong, the head of Automation Equipment Technology Section in TTI, Test Technology Innovation Department, Infineon Technologies, and Dr. Min Tu Su, the lecturer in Faculty of Engineering and Technology, Multimedia University. Mr. Lam will share with us how digitalization and automation are implemented in Infineon Technologies. Before that, let us welcome Dr. Min to share us a bit about the fundamental knowledge of automation. Okay, so Dr. Min received a Bachelor of Engineering in Mechatronics from Mandalay Technology University, Mandalay, Myanmar in 2002, and Master of Engineering in Mechatronics from Yangon Technological University, Yangon, Myanmar in 2004. He also received the PhD degree in Mechatronics from the Mandalay Technological University, Mandalay, Myanmar in 2007. So Dr. Min is a lecturer in Faculty of Engineering and Technology, Multimedia University, Malacca, Malaysia. His primary research interests include mechatronics, robotics, control system, and automation. He's a member of professional bodies such as Board of Engineers Malaysia, BEM, Institution of Engineering and Technology, IET, UK, and a senior member of IEEE Control System Society. So if you have any question that you wish to direct to Dr. Min, you may post them in the chat box, and I will get Dr. Min to answer them in the Q&A session. Dr. Min, the stage is yours now. Over to you, Dr. Min.
Hello, very good morning. I am Dr. Min from FET, Multimedia University. Today I would like to talk about automation and industry revolution. What is the automation? Automation is a technology concerned with the application of mechanical, electronic, and computer-based system to operate and control production. So, and also this automation terms is derived from the Greek words auto and methods, where auto means self, while methods mean moving. So automation means self-moving. So every day you are using this automation technology, but you did not notice that, just like the leaf smoke detector printer. But this leaf smoke detector printer is the built-in or fixed automation. And also like the street solar lighting, this is a light automation. But today our talk on industrial automation. So industrial automation, for example, automated bottle filling station, that is industrial automation. So today in this webinar I will talk only on the industrial automation. This technology, industrial automation technology, includes automatic machine tools to process batch, automatic assembly machine, industrial robot, automated material handling and storage system, automated inspection system for quality control, feedback control and computer process control, computer system for planning, data collection and decision making to support manufacturing activity. Automation system can classify into three types: fixed automation, programmable automation, and flexible automation. But this three type is a basic three types. Fixed automation is a system in which the sequence of processing or assembly operation is fixed by the equipment or configuration. The operation in the sequence are usually simple, but in fixed automation, it is the integration and coordination of many same operation into one piece of product. So that makes the same system complex. The typical feature of the fixed automation are high initial investment, high production rate, and relatively inflexible in accommodating the product changes. From the economic justification for fixed automation, it is found that in product with very high demand rate and volume, for example, mechanic assembly and machining transfer line, this is the example for fixed automation line. Another one is a programmable automation. In this type of the programmable automation, the production product is designed with the capability to change the sequence operation to accommodate different product configuration. The operation sequence is controlled by a program. In here, a program means a set of instructions coded so that the system can read and interrupt them. In this type of the automation, new program can be prepared and enter into the equipment to produce new product. Some of the features for the programmable automation are high investment, low production rate, flexibility to deal with the changes in product configuration. Mostly the programmable automation are used in low and medium production. Another one is a flexible. Flexible automation is the extension of the programmable automation, because a flexible automation system is capable of producing a variety of products with virtually no time loss for changeover from one product to the next product. And also there is no production time loss while reprogramming the system and altering the physical setup, such as tooling and machine setting. Therefore, the system can produce various combinations and schedule a product instead of requiring that they may be made in separate batches. The feature of the flexible automation system are also high investment, continuous production of variable mature product, median production rate. And the main one is a flexibility to deal with product design variation. So the example for manufacturing system, automation system, flexible automation system is a flexible manufacturing system known as the FMS. In here, You can see the product varieties, the 3 types of automation for different volumes and product varieties. So for the programmable automation are suitable for low production rate, and flexible automation are suitable for medium production rate. Fixed automation are suitable for high production rate. The main distinguish between flexible and programmable automation is the software changes and hardware changes. That means programmable automation has the capacity to change but program, and flexible automation has the capacity to change over the physical setup. In both of the automation, all the changes has a no loss of in production time. That means no change over time. So another type is the integrated automation. At the previous basic type, fixed automation, flexible automation, programmable automation. This 3 type is a basic 3 types of automation. Besides these 3 basic automation, another one is integrated automation. In this integrated industry automation involves the total automation of manufacturing plants, where all processes function under the digital information processing, coordination, and computer control. And therefore, in this type of the automation, computer-aided processing planning, computer-supported design and manufacturing, computerized production and scheduling control, automatic conveyor and crane technology are used for this type of the automation. And the previous 3 type automation don't have the coordination system. Only this integrated automation have the information processing coordination system. And also additionally, in an automatic integrated automation system can integrate a business system through a common database. So it supports the fully integration of management operation and projects using communication and information technology. Such technology, information and communication technology, are utilized in advanced projects automation system. As I mentioned earlier, all the automation systems are high initial investment, but still industry are using this automating. Why industry are using this automating? The first reason is a increased productivity. That means automation manufacturing operate increasing productivity of labor. This means when we use the automated machine instead of the human worker, the production rate will be higher than the human worker production rate. Another one is the high cost of the labor. Today, all the industrial society are facing this issue because the labor costs are increased every year. So to overcome this problem, all industry are trying to invest the automated production line. Because all the automated machine has to become justifiable, economically justifiable to replace manual operation. Another one is a labor shortage. So one, and also the all advanced nation, many of the advanced nation has been a general shortage of the labor. Because the labor shortage stimulate the development of automation as a substitute for labor. When you use the automation, surely this is a safety for human worker, because the human worker role is the supervisory role for automatic machine. And also when you use the automated operation, it's not produce the parts at faster, but also they produce product with greater quality certification. That means so improve product quality, and also reduce the manufacturing lead time. By reducing this manufacturing lead time, automation system allows the manufacturer a competitive advantage in promoting good customer service. As I mentioned earlier, the main objective of automation is to obtain high production rate and high productivity. So to get this high production rate and high productivity, we can by reducing the handling time, machining time, tool changing time, setup time, and then increase the plant production capacity. To do this, we have to there are certain fundamental strategies that can be employed to improve productivity in manufacturing operation technology. So some are I listed here. Specialization of operation, that means using the special purpose equipment, special purpose machine designed to perform certain operation. Another one is a combined operation. That means combine different operation involves reducing the number of distinct production machine, and so on. So I listed integration of operation, increased flexibility, online inspection. In traditional way, inspection are doing for after the process. So that means any poor quality product has already been produced by the time when doing the inspection. So when we use this online inspection, can reduce the scrap rate and also bring the overall quality of the product is a high quality. What is the main role of the automation in society? The main role is a better product quality, reduce demand labor for skilled labor. But in here, there are too many points can say mention for effect of human society. But here I'm point out only 2 points. The first one is a better product quality. This is a we can get a higher quality. But second point is a negative point because of reduced demand for skilled labor. Because nowadays more companies are turning to smart machine to save money on slow, expensive human employee. But that is not the new. Automation is happening before. Since 1969. So automation happening since 1969 because of the industry revolution. The first revolution is the begin in the 18th century. At the time, steam power and mechanical production are used for production line. And then second revolution. For the second revolution happened in 1870. So we can say 19th century. For this time, electricity and assembly line are used for industry. And then the third revolution, industrial revolution, industry 3.0. Starting from this 3.0, 1969, the term automation are starting use, but not a fully automation. This is a partially automation using memory, programmable control, and computers. But this programmable control and computer are still used in current stage. But this is a In 1969, this computer and programmable control is the introduction stage, introduction of this technology. So we are now able to automate the entire production process without the human assistant. For example, the industry robot. So the robot that perform program sequence without the human interference. So starting from the industry 3.0 in from 1969, the machine replaced for human job. And also now currently implementing the fourth industry revolution, industry 4.0. This industry 4.0 is a development of industry 3.0 by adding information and communication technology. But this time information and communication technology is expanded by a network connection and have a digital twin on the internet. So they allow communicate with the facility and the output of information about themselves. So the next step of the production automation is the autonomous production. They are using the networking system, so-called the cyber physical system. That means cyber, networking, and automation system physically are combined. So the networking of all systems lead to cyber physical production system, and therefore all industry factory are goes to smart industry. So in the simple word, they are saying the smart industry. So in this smart industry, the production system components and people will communicate through the network, and all the production is nearly autonomous. So for the smart industry, the main component needed technology is a IIoT, Industry Internet of Things, Big Data Analytics, Cloud Computing, and Automation. So to implement the Industry 4.0, first need to understand the main terms. Automation, but automation is starting from the Industry 3.0, but still used for the Industry 4.0, because Industry 4.0 is the development of the Industry 3.0. And also additive manufacturing, artificial intelligence, machine learning, industrial Internet of Things, cyber physical system CPS, cloud computing, big data analytics, IT and OT. These are key terms for Industry 4.0. So to implement Industry 4.0, how to implement Industry 4.0? To implement this, first you need to understand your starting position before you move forward into Industry 4.0. So the starting position means you need to understand the Industry 4.0 terms and technology. So first you need to train the staff about the Industry 4.0, and then develop the current machine based on your requirement of the Industry 4.0 technology, and then building the data-driven decision. So the main challenges for implementation of Industry 4.0 is what will be the main challenge? The main challenge is the shortage of the necessary skill, talent, and knowledge. So that means most of the staff, current worker, current human technician cannot understand about the IoT, especially for the IoT, AI, artificial intelligence, machine learning, and cybersecurity, and many other technology need to understand for Industry 4.0. So But for the Industry 4.0 is based on the in the automation technology. So automation technology is a necessary, essential for Industry 4.0, and also Industry 3.0 is automation. So Industry 4.0 is a development from Industry 3.0. Automation is there, therefore automation is essential for Industry 4.0. So, are you ready for smart industry revolution in fourth industry revolution? So, for to follow the industry revolution, smart industry 4.0, we need to learn a lot of new things like the artificial intelligence, machine learning, and so on. So we cannot stop our learning. Okay, so are you ready for fourth industry revolution, smart industry? Thank you.
All right. Thank you very much, Dr. Min, for sharing us the background knowledge of automation. That was actually a recorded lecture by Dr. Min. So due to emergency situation, Dr. Min will join us in the Q&A session later. So once again, good morning to all, especially to those who have joined us uh, just now. Okay. So modern day industrial automation has become a driving force in all production system. Development in areas like robotics, automation, and industrial vision has opened new capabilities in industry. So to understand automation in detail, we need to know how industry has grown in the former era. Industry have progressed from mechanized manufacturing to mass production, and from mass production to computerized manufacturing processes. Now, production industry are moving towards cyber physical systems and IIoT. This revolution in production requires for knowledge and skill development in different technologies such as artificial intelligence, IoT, additive manufacturing, nanotechnology, and many more. Next, we will see how digitalization and automation are implemented in Infineon technologies. So let us introduce our next speaker, Mr. Lam from Infineon Technologies. Mr. Lam Ji Cheong obtained his Bachelor of Engineering in Mechanical and Material from University Kebangsaan Malaysia in 1999 and graduated with Master of Manufacturing Engineering, Manufacturing System Engineering from University Technical Malaysia Melaka in 2021. Mr. Lam has over 22 years of working experience in semiconductor manufacturing industry, and he is currently holding the position of director and the head of TTI AET, Test Technology Innovation, Automation Equipment Technology in Infineon Melaka, focusing on technology partnership and ecosystem development, smart factory I 4.0, through equipment and MHA automation, integrating AI with automation systems. He's also the pillar lead for process control automation and spearheading the implementation of Industry 4.0 in Infineon backend. So again, if any question that you wish Mr. Lam to answer you, you may post them in the chat box. So let's welcome Mr. Lam. Over to you, Mr. Lam.
Nice, thank you. All right, thank you, Dr. Yo and the organizer, all right, for creating such a wonderful platform for us to come together for knowledge sharing and exchange of informations regarding automations and industrial revolutions. So before I start, I would like to share a story about a day's life of a typical engineer in the industry that I'm at. That's before the age of digitalizations, around 15, 20 years ago. Well, I used the best of my drawing capabilities for the example that I'm going to share, so please bear with me. Right. The first things. Okay. Let's name this stickman as Ali. So typically, Ali arrive in the office around 8 in the morning, and the first thing he needs to do, he has to go through tons of documents, equipment reports, productions report and status, U performance, SPC reports, and so on and so forth. So this usually eats up half of the day. And around 12:30, then Ali goes to enjoy his lunch break in the afternoon. And after his lunch break, Ali needs to go into the production floor, makes improvements for underperforming equipment, try to understand the issues, finding out what's the root cause. Could be sometimes challenging. It's not like the machine will talk to Ali and tell Ali, right, what's not well with it. So most of the time, it relies on Ali's knowledge and his colleagues' experiences and try and error. Yes, it could be quite unfortunate at that time, and because of that, quite substantial of time is used in collecting and analyze data physically and manually. And usually Ali ends his day after the sun goes down. So I hope my opening here won't deter the audience today from joining the exciting world of manufacturing sector. So in the upcoming slides, I would be sharing the changes in the industry has made or in progress of making, especially in finance. So before that, let's take a step back and understand why we are calling the current industrial revolutions as Industrial Revolution 4.0. The academia and industrialists determine that the first industrial revolutions is about the inventions of the use of steam technology industry, especially in the textile industry, right? With the invention of the flying shuttle by John Kay. The second industrial revolutions is about the use of mass productions, build of railroads, electrifications, and harnessing the power of electrics, right, into DC or AC power motor. The third industrial revolutions, or digital revolutions we call it, is the use of computers and automations in the industrial. Now, we are facing the fourth industrial revolutions. Is all about connectivity, changing the way we work, merging the physical and cyber world together. What makes Industrial 4.0 so different from the first, second, and the third is the novel way in which the hardware, software, and connectivity are being configured and integrated to have the collections and analysis of vast amount of data, the seamless interactions between smart machines, and the blurring between the physical and the virtual dimensions of productions. For examples, sensors might detect specific actions or process durations or ambient conditions such as temperatures, allowing for independent self-corrections according to the insights of big data and artificial intelligence. So these data points might also feed through the system in real time to adjust and optimize downstream stages of the manufacturing process, minimizing downtime, freeing up resources, and making the whole production lines more effective and less wastage. I guess those who are familiar with IR 4.0 or Industrial Revolution 4.0 will somehow see these technology pillars in one way or another. In short, Industrial 4.0 was coined in 2011 by a German initiative by the federal government in association with some of the universities and private firms to increase productivity and efficiency in the manufacturing sector. It's all about integrating the 9 concepts in industrial, especially in manufacturing, where they are currently being individually used and implemented. The lacking concepts will empower the factories to be intelligent, and that is what Industrial 4.0 is about. So in Infineon, the adoptions of Industrial Revolution 4.0, we adopt digitalization concept across all processes and methods. For Infineon, digitalization has 3 different aspects. Digitalizations of products and services, for example, the sensors needed for autonomous driving. New business model, for example, new business models around intellectual properties and data. Digitalizations and integrations of value change, which I will be focusing into these topics. In this context, Infineon uses the following definitions for digitalizations in value chains: generations and analysis of data to gain knowledge, make predictions, and automate decision making. Think about how your smartphones change the way you communicate and organize your life. Digitalization changes society tremendously, and most experts say this is just the beginning. The Internet of Things will still change many aspects of our life. Many people experience change as a threat or at least a challenge, but digitalization is an opportunity. We need to shape digitalization in such a way that it serves us. Digitalization is an opportunity to solve upcoming global challenges and demographic change and as well as urbanizations. Digitalization makes your lives safer. For example, in autonomous cars, it helps us to stay connected and offers new ways of interactions with machines. We want to use these potentials in Infineon by actively adopting digitalizations. I believe that digitalizations will make Infineon faster, more efficient, and more flexible. Digitalizations within operations fosters our operations excellence programs and also improve time to market. And today, I will present the Infineon ways of digitalizations within operations. The first three industrial revolutions didn't really care about the role of human worker. The industrial revolutions make humans work in loud, hot, and dirty factories with bad air. Humans had to obey to the tag of assembly lines and do repetitive tasks. Finally, the visions of the industrial revolutions was a fully automated factory without human at all. So this story did not go well for human workers, and you might fear this will happen again. So the fourth industrial revolutions is different. Industrial 4.0 recognized that humans and machines have different strengths and work well in a different environments. Humans are flexible and creative. They work in new and uncertain environments. Humans are explorers of frontiers of technologies. Well, robots are extremely fast and efficient, but they only work in a stable and standardized environment. Basically, they are good at tasks that human considers as boring. Key to Industrial 4.0 is to take the best of both worlds and relies on collaborations. Collaborations with robots enables humans to focus on creative and value-adding tasks. While working on the topic, we look into a lot of scientific articles, consulting, and government publications. And in all of them, sometimes in different names, and sometimes with a bit of different scope, but in all of them, we found four field of actions. And these four field actions of Industry 4.0 and Infineon. First is integrations. It's all about connecting, bringing the data together. Big data and analytics is about distributed computing and advanced analytics algorithm. What we can do with the data that we have. Automations 4.0 connects the physical and virtual world, making robots smart. And finally, digital work life, which focuses on new ways of collaborations between humans and machines and between humans. For example, remote working. The upper fields are focused on data, and the fields at the bottom create the link to the physical world. On one hand, to automations, and on the other hand, to humans with new forms of interactions. These technologies are advanced, and of course, they're built on the prerequisites. As enabling fields of actions, we identify securities, data quality, and automation 3.0. The field of actions are general. They offer advanced technologies, tools, and methods that can be applied in a completely different areas and processes. All serve to our Infineon's targets to improve time to market and operational excellence. And they contribute to our existing initiatives, our next level of productivity, next level of R&D, and next level of zero defects programs and speeds. On the following slides, I would want to introduce the four field of actions in more details and highlight the visions for each field of actions. Right, let's start with integrations. The vision for this field of actions is to have a full integrations of the whole value chain in real time. And with the whole value chain, we really mean from the first idea to revenue. So this means the integration along three dimensions. The first one is from planning to our front end and back end, all the way to distribution center to the customer. The second dimension is between the shop floor to the company level to our company targets, for examples, or our KPIs. The third dimension is between development and production, from idea to innovations to implementation, which actually exhausts to horizontal and vertical integrations, for example, supply chain integrations, product lifecycle management, real-time communications, Internet of Things in supply chain and manufacturing, connecting everything into one network. Integration creates a new level of data availability and transparency. With transparency, we can improve the coordinations between different parts, which is necessary for global optimizations. The continuous availability of data is the basis of big data and analytics. One example of digitalizations that we have in our production floor, right? By introducing auto dispatch and scheduling systems, our lots are automatically scheduled in the production floor on a real-time basis. Mobile devices in the production floor, assigning most suitable technicians to the equipment downtime to reduce downtimes and to improve effectiveness. The overall control tower to monitor the conditions and to provide assigned interventions or support when needed. The control tower, or we call it MAS, which stands for Manufacturing Actions and Response Satellite, transform the traditional way of data collections, problem analysis, and communications method from production line manually to a centralized command center, which with the mobile device for closed loop communications. We even have dedicated trained employees, we call it MAS rangers, who run the activities from the MAS room. So in the second field of actions here, today, everyone talks about big data and new advanced algorithms like machine learning. Well, everyone talk about it, but most people have a different understandings of these terms. Therefore, we start by defining them, creating a common understanding. Big data is cluster computing and distributed storage are necessary to handle analysis of data which is unstructured, high volume, and real time. This corresponds to Gartner's three view definitions: variety, volumes, and velocities. But the terms are easier to understand and well known here in Infineon. So basically, it is the basis for working with large amounts of data, storing, handling, processing, but not yet analyzing. Advanced analytics. Analytics methodologies or algorithms used for predictions and automated decision makings. For example, machine learning, predictive analytics, or multivariate statistics such as neural networks and etc. They may not be new, but today we have the computing power and the amount of data to really make use of them. So this is the part where intelligence comes in. The vision is to use advanced algorithms to analyze data in order to generate knowledge and trigger actions. Now we have the first glimpse of intelligence. We have algorithms that create knowledge and can trigger actions, and actions need to be executed in real physical world. An example of how data is being collected, used, and analyzed to generate actions in physical world. By collecting equipment performance data in real-time basis, in this case from a wire bonding equipment, right, by introducing advanced analytics algorithm, we are able to determine the performance of the bonding, right, between the good versus the bad based on data collected from the equipment's deformation distance. With this, we are able to diagnose accurately the machine performance, right, and equipment can be stopped automatically to prevent catastrophic quality products from flowing out from the factory. Actually, today, most robots are stupid. They run on rails and they are controlled by a simple if statements. If you reach at the end of the rail, turn directions, and the knowledge behind these if statements is given by the programmer. Modern robots, machines, and devices are getting smart, connected, and collaborative. They don't act in a cages separated from humans, but in the same space and work cooperatively. Robots are highly flexible and can adapt. They are assisting to human workers. These robots are smart because they connect to the virtual world, the data world, with the physical world. They receive sensor informations, process the informations, and decide. The decisions are then executed in the real world. They may even assist a complete digital shadow or digital twin, we call it, within the simulations that can try out several possibilities in the virtual world before executing in the physical world. Main technologies and methodologies we are focusing here are cyber physical systems, connecting digital to physical, automations of decisions, also known as automations of knowledge work. Autonomous robots, the best image for these technologies are automated guided vehicle or AGV. Right, a clear example in our Infineon Malacca plant. A fully automated packing line of placing our end products into a destination box, printing the required labels and instructions by replacing our labor-intensive repetitive works. A fully automated 5-story high storage system to store and transport our WIP materials from one area to another automatically. An automated transport system to link the material movement to the last miles, from storage to in front of the equipments, eliminating humans of the needs and hassle to search for the correct materials to fit the machines. And this improves safety, ergonomics in the factory working environments. The human worker needs to control and steer this digital orchestra, just like a conductor. Therefore, we need, on one hand, a new interfaces to the digital world, but on the other hand, also new competencies. All these changes and developments have implications on human workplace. They need to be employed in such a way that they provide a benefits for the human worker. New ways of collaborations between humans and machines, and new human machines interfaces create a link between the data driven world and human creativity. This ensures that humans can concentrate on creative and value adding tasks. Only if interactions and collaborations between humans and machines work, the potentials of combining both strengths can be unlocked. This field has two sides: the change in the working life of the technologies enabling digital collaborations. The main technologies behind this are new human machines interactions, for example, augmented reality, assistance systems, and even remote services. Although Industrial 4.0 is built around humans, there are still changes in the culture and the way of working, which needs to be considered. For example, competency management, mindset leadership, and change management needed in the factory. Right, to summarize, we have 4 fields of actions: integrations, big data and analytics, automations 4.0, digital work life. In each field, different levels of digitalization can be reached. Digitalization is not a threat, but an opportunity for us to become more effective and generate more values throughout the whole value chain. The use of data in real-time manners to generate positive values, such as machine learning, predictive and prescriptive maintenance of machines. It is not just about having a fancy robot in the factory. The core of digitalizations is collaborations between humans, robots within the workplace. And before I end, I hope you can enjoy the video that I have prepared, showing what Infineon means by automations and digitalizations of manufacturing environment in industrial revolutions in mind. Encik Buhan, if you may.
Since year 2018, Infineon Malacca has embarked Industrial 4.0 transformation, digitalized agile production and manufacturing systems journey. We continue to innovate in our complex environment, and our commitment enabled us to deliver result effectively and efficiently. Since 2019, Digital Packing Line packed and shipped close to 3 million reels of automotive products from Malacca to our customers around the globe. Highly efficient integrated storage and handling automation. With IoT, it's enabled data-driven automated deviation detection and decision. Intelligent shop floor enables us to proactively detect and respond to events. Our Industrial 4.0 transformation journey continues.
Right, I hope you enjoyed the video. Back to you, Dr. Yo.
All right. Okay. Thank you very much, Mr. Lam, for the wonderful video and also insightful speech. Just to summarize, okay, innovation is always at the center of our civilization and is a driving force in the current industrial manufacturing sector. So in Infineon, digital and automation innovation are embarked with data-driven in manufacturing for productivity, efficiency, quality, and flexibility, which encompass with four main areas: digitalized agile production and manufacturing system. Two, data-driven automated deviation detection, prediction and decision. Three, highly effective self-managed digital work life. And four, integrated storage and handling system. The digitalization journey will bring the organization into technological and digital innovation in the areas of material handling automation, artificial intelligence, data analytics, industrial IoT, and much more. Okay, so now we'll have our Q&A session. And again, we're proud to welcome Dr. Ming with us and also Mr. Lam to answer few of the questions from the floor. Right, so let's have a look at the question. Okay, the first question. Okay. All right, so over here we have frequently heard about the Industrial 4.0. So we want to know, so there's one question like this: which engineering and technology qualification will be needed for Industry 4.0? Right, maybe we can have Dr. Min to try to answer this question. question.
And thank you, Dr. Yu. I think this is a very good question for qualification needed for Industry 4.0. So for the Industry 4.0 is a digitalization cyber physical system. So the require engineering and technology qualification will be the main one is automation, and then mechatronics, robotics engineering, IoT. There's a computerized computer engineering, artificial intelligence, and also the last one is machine learning, and also we need the machine vision. This is just some requirement qualification for Industry 4.0. Thank you.
All right, thank you. Okay, we have seen the, I think during the presentation, by Mr. Lam, we have seen how digitalization is happening in Infineon technology. There's one question like this: which other industrial sector that are suitable for industry 4.0 migration other than manufacturing industry? I think maybe Dr. Mi can try to answer this one also.
Yes. Mr. Low also mentioned the IM 4.0 migration in the industry. But rather than this manufacturing, the other industry will be like the service industry, also suitable for Industry 4.0 migration. And also, actually, Industry IM 4.0 can be used for all industry situation where process need to more intelligent, and especially in the automotive and agricultural sector. That is also suitable for Industry 4.0 migration. Thank you.
All right. Okay, thanks for the answer. Um, okay, so we know that the automation and digitalization are important to actually drive uh, the transformation. All right. So, but there's a question. I believe many of us is actually asking about it. Will or does the automation kill the job opportunities? I believe this is an important question for many employees. So maybe we can have Mr. Lam, right, to answer this.
All right. Thanks. I think it's an important questions that a lot of people is asking, right? Be it upfront or asking themselves inside their heart. Actually, automations is a natural cycle of human development, right? By implementing automations, we are able to reduce human interactions with the objects, but we do not mean that we reduce headcount. Whereas the opposite is true. Automations creates higher levels of jobs to the society and nurtures the current low level jobs into skilled employees, right? From you doing the manual or boring work of transferring materials from locations A to locations B, this can be replaced with AMR or AGV. And while you become the new owner of the systems, right? Doing sustaining works, programming new and more effective ways of the routings, integrating it to other automated systems in the factory. So I think in a nutshell, automations will actually benefit us in humankind and to workers, but then we have to upskill and we learn let's say new tasks so that we can actually keep ourselves sustained. Yeah, thank you.
All right. Okay. Thanks for the answer. Okay, I believe this answer gives some confidence to the current employees, right? And many of us, right? And the situation actually happens, I think, frequency industry. Okay. If you can remember, the time when computer was first brought into the industry, in the work environment, working environment, right? So many believe that the computer will replace human, right? So now see around us, right? We are actually dependent on computer. We are actually working around with computer PC today. So I believe automation will be similarly, right? And there's actually one fact from an article that I actually read. Okay, the World Economic Forum predicts that 65% of children entering primary school today will ultimately end up working in completely new job types that don't exist today. So mean to say in 10 to 15 years to come, we'll progressively see the market demand for job will be changing, right? So that's the situation and the fact that we have to accept. right? I think start from now, right? So so another question from maybe from my side. So what do we expect to see in Infineon Malacca within the next few years, right?
I would
Ms. Lam?
comment on the technical aspect of it. In our roadmap that we want to move forward in terms of digitalizations and automations for Infineon Malacca, we definitely seriously embarking into this journey, improving the competencies of our employees, both exam and also non-exam staff in the areas of robotics, AR programming, automation engineerings, factory integrations, and many more. We are getting in new talents to join us as well. We are expanding. We have a new building coming out, and this will actually give us additionals of around 50,000 meters square once this is complete. We are putting in the highest technologies of factory automations into this. We are already at 9,000 plus employees, active employees in Malacca. We expect our family to grow even larger in the coming years. And this expansion, we are not seeing it alone in Malacca. We are seeing the expansions happening throughout the whole Infineon globe. Be it in Wuxi, China, in Regensburg, Germany, in Washstein, Hungary, and many more places. Right. So then, it's exciting futures in Infineon coming soon, I would say. Thanks.
Yeah, yeah, great to hear that. So I believe we can see more and more things from opinions. I think we very very soon. I think we are near to the end of the webinar, right? If you have more questions, you can feel free to actually put on a chat box, right? So we will try to try our best to actually answer you maybe later, right? Through I think replying to the chat box, right? So before we end the session, right? Let's have Mr. Lam to give a closing remark, right, for this webinar.
Right. Thanks, Dr. Yo. First and foremost, I would like to express my appreciations to the organizing committee, right, for giving me such a wonderful opportunity to be part of the MMU Webinar Series. With the emergence of internet, spark the growth for connectivity, and thus give birth to the fourth industrial revolutions. As the title of today's webinar stated, automations and digitalizations of manufacturing environment with industrial revolution in mind, we can see that with automations and digitalizations will provide advantages in improving productivity. Productions processes are being automated in a controlled manner, improve accuracy as machines are less prone to make mistakes compared to human labor, improve safety. Machines is ideal for tasks that are too dangerous for human to undertake, improve quality. Manufacturing process can be managed in a controlled environment, even with high complexities parameters. And lastly, improve repetitivity. Where it comes to repetitive works, machines can get it done more in a less time and more precise. Lastly, John F. Kennedy, the 35th President of the United States, once said, "Automations does not need to be our enemy. Machines can make life easier for men if men do not let machines dominate them." So I hope the participants today benefits something in a one way or another. And with that, thank you and Merry Christmas to those who are celebrating it. And for the rest, Happy Holidays and Happy New Year.
All right, thank you, Mr. Lam, for the wonderful closing remark. So before I end this webinar, I would like to thank first our speakers today. So there are two, Mr. Lam and Dr. Min, for your wonderful and fruitful sharing. The organizer of this webinar, the Industrial Collaboration and Engagement Center, ICEC, and Research Industrial Collaboration and Engagement, RISE Division, the co-organizer, uh, uh, the Center of Advanced Robotics, okay, and the members of Faculty of Engineering and Technology, Strategic Marketing, Admission and Recruitment, SMART Division, MMU Studio, and the technical support team for making this webinar conducted smoothly. And of course, right, to all our audience here, thank you for your time in joining us, right? Every one of us, take care and stay safe. Thank you very much, and see you again.